Well, it is an honor to be invited back again. That's kind of how you know you were reasonably successful, is if they invite you back the second year. You can fool everybody the first time, but I had a marvelous time in Budapest a year ago. Thoroughly enjoyed your city. Took the boat ride up and down the Danube and just had a great time. Of course, my girlfriend was here with me last year, and she's not here this year. So it'll be a little more difficult. Before I start, I want to remind you that in your bags is an evaluation form for the day. And I know the conference organizers would like you, as you listen, to give evaluations and turn these in at the end of the day. This is very important, and I run a number of conferences in the U.S., and these evaluation forms ultimately get back to the speakers, and it's your way of chatting directly with them and giving them some advice or comments. So if you would do that today, I know the conference organizers would want you to do that. All right, I'm here to talk about the mismeasure of software. Now, this is subtitled "The Last Talk on Measurement You'll Ever Need to Hear." There's actually a subtitle under that which isn't shown, which is "If You Pay Attention." If you take my grandfatherly advice. So the topics for the day are these. I'm going to talk about what is measurement. I'm going to provide you with what I call the 4 don'ts of measurement. And then I'm going to talk about my favorite current indicator, some past measurements I've liked, but current indicator that I like, and it turns out it isn't a measurement at all. And then we'll end with what I call Lee's Zeroth law of measurement. So that's where we're headed today. So let's start with this definition of measurement. This is from Kem Kainer. If you don't know Kem, you should. He's author of Testing Computer Software, the #1 best-selling book in English on testing software. Kem says this: measurement is the empirical, objective assignment of numbers according to a rule derived from a model or theory to attributes of objects or events with the intent of describing them. And that's kind of a long sentence. That's a mouthful. But each of the things in here is important. We'll talk about those. I want to start, though, with a classic example of measurement. It's called phrenology. Don't know if you've ever heard of this science. But the idea is that we can tell a person's interests and abilities and skills by feeling the bumps on their heads. And so let's refresh our memory here, if you're not familiar with phrenology, on some of the basics. The brain is the organ of the mind. Now, modern medicine believes that today. The ancient Egyptians thought the brain was some kind of cooling mechanism. It's like a radiator. But today we know that the brain is the organ of the mind. The brain is not a homogeneous entity, but it's an aggregate of different pieces of mental organs with specific functions. We know that certain parts of the brain deal with certain kinds of memory, certain kinds with speech, certain parts with hearing, and so on. And we know that these organs are topographically localized. They're in different places in the brain. And if you notice all those are in green, that's because medical science tells us this is true. Now, in orange, the relative size of any particular mental organ indicates the power or strength. That was a key idea in phrenology, but we're not so sure of that today, scientifically. And in red, external measurement can be used to determine the internal states of our mental powers. That's the idea of phrenology, that we can feel the bumps on a person's head and tell some things about them. Now, I need a volunteer from the audience. Would you volunteer? Would you bring a chair? I forgot to load a chair up here on the stage. Now, this is Tuhita Parveen. She's going to be a keynote speaker today. I'm going to put my, would you just put this sideways here? And let's see. In fact, let's do it over here so I can see a little better. Would you mind? Now, I'm going to put my hands on your head. That's all I'm going to do. Is that all right? Yeah, I'd like you to sit down. Is that okay, though? Okay, because there are laws, about things. All right. So, thank you for volunteering. Phrenologists determined that there were various aspects, and you could tell about a person by feeling around on the bumps on their head. And so let's start with this one right here. This is cautiousness. And cautiousness is, you see, it's just above and back behind the ear, about halfway up. It's about right here. Nothing. Flat, smooth. Okay, obviously not a cautious person. All right, let's look at this one, kindness. Now, kindness is right here at the top. Oh, there's a bump right there. Can you feel that when I do that? A very kind person. All right, let's look at the next one here. Sexual love. Now that's back here behind the, hold still. Back here behind the, let's see, just right about, holy moly. There's a giant bump right there. We need to talk later, all right? All right, would you give our volunteer a big hand? Thank you. Now, at one time, back in the late 1800s, phrenology was the science. The President of the United States went to experts to have his bumps read. Congress, senators, politicians, people of wealth and power would go have their bumps read. And you pretty well can guess what they found out, right? That they were smart and powerful and wonderful people. This became so popular that they couldn't keep up with the demand manually. They had to actually create an automated device for this phrenological analysis. It was called the psychograph, and the inventors got about $200,000 at the 1934 Century of Progress Exposition in Chicago. And $200,000 in 1934 dollars is nothing, I mean, it's millions today. This was so important that some employers even required certifications before hiring employees. Notice the two words that I put in red here, automated and certifications. Words that are familiar to testers, but I'm not going to say any more on that. Okay. Today we don't believe in phrenology. It came, it went. It was a measurement fad that really had no basis in science. So I want to give you some advice about not making the similar kinds of mistakes in the future. Do you notice something interesting about Kahner's definition? It required only the intent that the measurement be useful. It didn't actually have to be useful. And while I like most of his, let's flip back to his definition here. While I like most of it, I don't like this idea with the intent of describing them. I think we have to do better than just have an intent. All right, so let's skip through this. There are two basic causes of measurement error. I see these all the time. And they're called the map territory error and the reification error. I don't know if you know this guy. He's a favorite on young people's television in the United States. This is the count. He likes to count things. And so a reification error is an error in counting. So let's go back through this definition again. Measurement is the empirical objective assignment of numbers according to a rule derived from a model or a theory to attributes of objects or events with the intent of describing them. There needs to be some kind of model or theory behind our measurements, behind our metrics, behind the assigning of numbers. We just don't arbitrarily assign numbers for the fun of it. We don't just arbitrarily say, well, that looks like a 6, and that one over there looks like a 10. Okay? There needs to be some model or theory, some basis behind. And a common mistake that people make in metrics is confusing the model with reality. The model is not reality. The model is a model. The map is not the territory. There's an apocryphal story, I don't know whether it's true, and it's, sometimes it's a Swiss army and sometimes it's a Finnish army, but the idea is the same, that if you're standing on the ground somewhere and you're looking at a map and your feet are wet, there is a stream there, whether the map says so or not. The map is not the territory. The territory is the territory. Those of you who can read the French, what does this say under this pipe? This is not a pipe. What is it? It's a picture of a pipe or a model of a pipe. It is not a pipe. Okay, the map is not the territory. Now, George Box, a great statistician, you may know about box plots. Those were named after George Box, not because they're rectangular, but because of his last name, Box. Box once said this: all models are wrong. Some models are useful. All models are wrong. I was working with my 12-year-old grandson just the other night. We were talking about the Bohr atom. Remember the nucleus inside, and then spinning around the nucleus are the little electrons. It looks just like a mini solar system. It's a great model. It's wrong. It's not the way atoms work at all. But it's useful. Like 90% of physics can be done using that model. Okay? So, mathematical models, simulation models help us understand the world, but we shouldn't confuse them with the world. If your feet are wet, there's a stream there, whether the model or the map says so or not. So I want to warn you that models and maps that we create often are wrong. They can just be plain old bad ideas. And I've got some examples of bad ideas here. Phrenology is one. It's one of my favorites. Reaganomics, I don't know if you're old enough to remember that. That was the idea that if we just give rich people more money, that somehow it will trickle down to those of us who don't have quite so much. And as you can tell here, they're just having a good laugh over Reaganomics here, because that's how rich people got rich, was not by letting it trickle down to us regular folks. Okay? It's a model, it's a theory, it's wrong. I don't mean to offend anybody, but I don't believe in neuro-linguistic programming. I think it's a model that's just wrong. The fact that I'm now looking up and to the right means nothing except that light's shining in my eyes. Okay. And another one is subliminal advertising, that we go to the movies and for just a moment on the screen, just for a 16th of a second, it says, buy popcorn, or something like that, or you are mighty thirsty right now. And we all, get up and zombie-like go out and buy more popcorn or buy some soda to drink. These are maps, theories, models that are just wrong, and there are lots of them. The world is full of models that are just wrong. Now, they might be useful in some situations, but they're wrong. Okay. So that's the map territory error. That's a mistake that people make a lot in metrics. They believe that their model is a representation of the real world when it in fact isn't. Okay, let's look at the next kind of error. Again, we'll go back to Kahner's definition. Measurement is the empirical objective assignment of numbers according to a rule derived from a model or a theory to attributes of objects or events with the intent of describing them. Metrics should describe things about objects or things about events. Okay? Now, a reification error occurs when we try to measure something that is not an object or an event, like an idea. And then we start to treat that idea as if it were a physical event, a real thing. We then try and talk about the metrics as if they really applied to this idea. Counting these things is dangerous. And comparing the counts of one thing against another is even more dangerous. Tibor, how many ideas did you have today so far? Give me a number. What? 100 ideas. Bob, how many ideas have you had today? 0.25. Obviously, Bob's the slacker, right? He's still asleep. He's on Boston time. Tibor, on the other hand, is doing well. You know, do you believe those numbers? Of course not. They're numbers that reflect ideas. One of my favorite television commercials, I haven't seen it in a long time, is a Delta Airline reservations agent talking on the phone. And it's at the Army camp where the entire platoon has been released to go home. And one after another, they come and get on the phone with the same agent and make reservations to go places. And at the end of a long period of time, the supervisor comes and asks the agent, how many calls have you processed in the last hour? And the answer is 1. Okay? Obviously a terrible reservation agent. Could only process 1 call. Okay? So, beware of this thing called reification error. It's the counting of things that really aren't countable. We do this because it's easy, and it's fun, and it makes people happy, it satisfies management, and so on. Okay? Now, let me give you some examples here, some classic examples. How about intelligence? Do you think you can reduce intelligence to a single number? How many of you know what your IQ is? Okay, do you believe it? Is that you? Is that all of you? No, it's a portion of you, maybe. Mine happens to be a very large number. It means only one. I discovered this many years ago. It means only one thing. I am really good at taking IQ tests. I'm not particularly good at anything else. Okay? Performance. How many of you have performance appraisals at your organization? Like every year you have to, and they give you a number, right? You're a 3. Bob, he's only a 1, Or you're a 5 or something like that. Is that your performance for the year? Can you really boil it down to a single number? And I love these, things like commitment. Well, Lee, you're not very committed to the organization. Oh, well, how committed am I? I think you're a 6. Okay, where did that come from? Or motivation, or leadership, or attitude. My wife said that just the other day. The kids have a bad attitude about homework. No, they don't have a bad attitude. They just don't do it. Okay, I don't know what their attitude is. Attitude is some internal thing that I can't sense. I can look at their report card and see that they don't do and turn in their homework. That's a behavioral problem that we could go address. But calling that attitude and assigning it a number like 3.2, it doesn't help. These are all examples of reification errors. Now, would that it was just them that did this stuff. But guess who else does it? We do too. Because we count stuff all the time that's really not countable. Oh, you may feel like this sometimes. How many of you count requirements and report that on some kind of a few? All right. Requirements all the same? Same value, same size, same worth, yet they each get a count of 1, don't they? That somehow seems strange. How about test cases? How many count test cases? Oh, come on, raise your hands. Everybody counts test cases. How many did we plan? How many did we create? How many did we execute? How many passed? How many failed? Are they all the same size? Are they all the same importance? Are they all the same worth? Of course not. But we count them. Why? It's easy. It's easy. Okay? How about defects? How many of you count defects? Yeah, come on, everybody, raise your hand. We all do that too. But again, what is a defect? Well, a defect is, first of all, it's in the eye of the beholder. Works as designed. You've heard that expression before. Are defects the same size, the same worth, same importance? Of course not. Yet we count them as if they were grains of sand, grains of rice, grains of wheat. All those other things are what we call in the legal profession fungible. Fungible is a great word. Everybody should know that word. It means they're substitutable. You can't really tell one from the other. When the farmer puts in 10 tons of wheat into the silo at harvest time and then comes back later to get 10 tons out, does he want his 10 tons down to the kernel? No. He just wants 10 tons of wheat because it's fungible. One wheat grain is just like another. And that's not the way these things are. So every time we count them, we're making a reification error. We're making a mistake. So don't do that. I went to the doctor the other day. I said, "Doctor, it hurts when I do this." See, this arm goes way up here. This one only goes up to about here. I said, "Doc, it hurts when I do this." And the doctor said, "Don't do that." Right, it's an old American joke. I hope it's a Hungarian joke too. So I'd like to give you 4 don'ts of measurement. And when you go to a public speaking class, they always tell you now, when you got really important points, you should have concise, precise names for things, little tags that people can hook onto this concept in their mind and take it away. And so I've done that with these 4. They're called don't number 1, don't number 2, don't number 3, and don't number 4. Okay? You ready for them? Don't number 1. I don't think this is rocket science. I think this is just regular, smarts. Don't measure it if you don't know what it means. I don't know if you're aware, but years ago, Bob wrote a marvelous book on object-oriented testing and a huge taxonomy of all the different kinds of errors that we can make. It's a big book. Over 2 kilos. I took it down. I wrote a book review on it. I don't know if I ever told you this. I wrote a book review, and I took it down to the grocery store and weighed it, like a head of lettuce. The book actually weighs twice my son's birth weight when he was born. My son was very early and premature and stuff, but Bob's book weighed twice what my son weighed. And in the early days of the object-oriented paradigm, there were all kinds of metrics. One of my favorites was superclass to subclass ratio, or subclass to superclass ratio. Measure how many subclasses, how many superclasses, and we would measure these things, and yet nobody really knew what it meant. So let me give you some examples here. First of all, I think there are some things that we legitimately want to know about. I would like to know about what's the size of this program. How big is it? I'd like to know about the thoroughness of my testing. I'd like to know about the quality of the product that I'm planning on shipping. I'd like to know if I have good system design. But for each one of these things that I would like to know, we create a substitute metric, a metric that allegedly represents it, but I'm not quite sure it does. Is lines of code really a good metric for program size? Not sure. Does number of test cases really measure the thoroughness of our testing, or just our ability to crank out a lot of test cases? Okay. Does the number of defects found really tell us about the quality of the product? What if we found 0 defects in the product? What does that tell us? Well, it could be an incredibly high-quality product, or what else? Terrible testing, right? You know, we just can't find a defect for stumbling on it. And subclass-superclass ratio. Nobody could tell me, for example, whether it was like golf or bowling. In other words, are high scores better or are low scores better? And what's a good range? You know, like 1 to 1 to 1 to 10, or 1 to 20, or 1 to 50, and when should it be high and when should it be low? Nobody could tell me those things. Okay. So the first don't is don't measure it unless you know what it means. If you have a metric that's a substitute, a surrogate for something else, make sure it really closely ties to it, because most of them don't. That's the key there. Okay, don't number 2. Don't measure it unless you're going to do something because of that measurement. How many have ever felt like the person standing here in the cartoon? Raise your hands high. We go to all this effort to measure things, and yet nothing seems to change. No one uses those numbers to make any kind of change in our process or our procedure, in the way we do business, the way we think about things. It's just thank you very much and into the wastebasket. So don't measure it unless you're going to do something because of the measurement. If you do this, your staff is going to think you're a clown or an idiot or something else, probably unprintable here. All right, don't number 3. Don't focus on measuring effort. And we do this all the time. Number of test cases created, number of executed, number of passed, number of failed. We measure our effort. Why? Because it's easy. What really should we measure? Accomplishments. Okay? If you were to measure the let's not pick on anybody, but like the quality of a diesel engine, for example, would you measure how much fuel it uses? That's the effort we put in, right? Or would you measure something else, like horsepower and torque and things like that, and maybe even emissions, if it weren't turned off? We should measure our accomplishments. Things like how many defects did we actually find before production? How much did that save our organization because we found those? We should focus not on measuring effort that goes in, we should measure accomplishment that comes out. But this is harder, right? This is more difficult. That's why people don't do it. Number 4. Don't turn your measurement into a goal. I've known this for years. I did not know that it had a name. It's called Goodhart's Law, proposed in 1975 by Charles Goodhart. Now, he's got a pretty good resume here. Former advisor to the Bank of England, emeritus professor at the London School of Economics, a person you'd probably want to pay attention to in this idea, in this field. And he says, don't turn your measurement into a goal. Goodhart's law states this: once an indicator is made a target for the purpose of guiding policy, then it will lose the information content that originally made it useful. And he goes on, any observed statistical regularity will tend to collapse once pressure is placed on it for control purposes. What does all that mean in regular English? Well, Marilyn Strathern, who's a professor, stated it much better, more succinctly. She said, when a measure becomes a target, it ceases to become a good measure. Okay, why? Because people know they're being measured on that and rewarded based on that, and so they kind of fudge the system. They'll do more of one thing or less of something else to achieve that numeric goal. What started out as a really useful measure can quickly fall apart. And so the classic example is lines of code. Lines of code per programmer per day. How many of you have been measured on that, or been in an organization where people were measured on that? Anybody? A few? Okay, what happens? Well, people quickly figure out that if they write more lines of code, they get better rewards, so they write more lines of code. That becomes not a useful measure of productivity or anything, but it becomes the goal. And so, here's the classic Java for loop. It's got, how many? Well, it's one statement, right? We start with some variable, we initialize, we define when we quit going through this loop, we define the increment, and we define a set of statements that we execute while we're doing this loop. So this example says, let's create an integer called I. It starts at 1. As long as it's less than 11, I'm going to execute this statement called print line. And at the end of each one, I increment I by 1. That's what the I++ means. But if I'm told that I'm rewarded for writing more lines of code, I will write the same functional equivalent with 4 lines of code. Okay? I have just increased my lines of code by 400%. And I've probably done it in about the same time that I'd write the classic for loop, which means I've increased my productivity by close to 400%, according to this metric, which is bogus. It's wrong. It hurts when you do this, so don't do that. Okay? Now, how many think lines of code is pretty old school, right? We do this agile stuff now. We don't count lines of code. Why? That's something our parents and grandparents did. Well, Goodhart's law reminds us that there may be unintended consequences just around the corner. And if lines of code is kind of old school, how about velocity? How many of you are agile? Measure velocity. Have you seen this? Velocity started out kind of interesting, right? It was, well, how much stuff can we build per unit of time? How many user stories can we accomplish in a week? And pretty soon, what did managers do? They set goals. And then teams started to figure out, well, how do I increase my velocity? And of course, the simplest way is to write user stories that are half the size as the ones you used to. Now you have twice as many of them. Okay. Goodhart's law basically says if you put people in a position where they're rewarded for hitting some numeric goal, they will figure out how to game the system. They will figure out what to do to get points, to win the contest, to do whatever, as opposed to what we're really trying to accomplish. So don't do that. Okay. So those are the 4 don'ts. Now let's see if, given those clever names, we can remember what they are. Don't number 1 was, don't measure it unless what? Unless you know what it means. Right. Don't measure it unless you know what it means. Measuring lines of code is one of those things that people are still debating over, and it's only been 40 or 50 years we've been debating over that. What is a line of code? I don't know. Okay, don't number 2. Don't measure it if you're not going to do anything with it. Okay? It's just a waste of time. It frustrates people. Don't number 3. Don't measure something instead. Don't measure effort, measure accomplishment. That's really what we care about. Okay? And don't number 4, don't turn your measurement into a goal. If you do, it ceases then to be an effective measure, because people will adjust their behavior accordingly. They'll gain it. All right. I want to talk now about my favorite indicator these days. Isn't a measurement at all. When I was a fairly young and foolish manager, lines of code was interesting to me. Measured that stuff. Later on, I kind of went out of disfavor, and I focused on percentage of test cases passed. I thought that was important. Maybe what I should have focused on was the test cases that didn't pass, the ones that failed and why. But again, young and foolish. Then I got into more formal measurement stuff and got enamored with defect density. You know, defects per 1,000 lines of code or defects per module. Turns out that there seem to be error-prone modules. Some modules are just good, and some that just are horrific. The errors, the defects, are not just uniformly spread through the code. So knowing the defect density was a useful thing. And then I met Dorothy Graham, who convinced me that defect detection percentage was the coolest thing in the world. This is essentially the percentage of defects that you discover in test versus how many your customers actually discover in production. I think that's a useful thing. But these days, none of these are my favorite. I've adopted something different. I discovered, I went on an actual family vacation this last summer. Took the kids up into the mountains, put them out on the boat, sent them out to fish, and I sat on the shore and read Bob Galen's new book called Agile Quality and Testing. And he has a really interesting set of metrics in this book that I think we all need to think more about. I certainly do. He likes the idea of predictability, value delivered, quality of the product, and team health. I'm not going to go into the details in these, but I think this is a better set than we've often played with in the past, and think we should evaluate and investigate these more. But I want to tell you about my favorite indicator. Now, it's going to be a surprise to you. Are you ready for a surprise? Okay, my favorite indicator is surprise. That's it. Surprise. Okay, well, maybe you're not as surprised as I thought you'd be. I like surprise. What is surprise? Well, it's to discover suddenly or unexpectedly without warning. It's to become aware of something not previously perceived. I like this one because I'm an old mathematician. A spontaneous awareness of a discontinuity in our understanding. At one point, this is what we understood, and then a moment later, we understand something totally different. Like, there is not a line of taxis waiting for me at the hotel in the morning. Surprise! Okay. I discovered that suddenly and unexpectedly without warning this morning. Okay. I think surprise is a great indicator for all of us to use in software development. And there are two things we could examine. We could examine the surprise itself. And then we could examine why we were surprised. Okay? So the developers come in and say, remember how we were on schedule yesterday? Well, today we're 3 months behind. Surprise! Okay. Are we surprised? Should we be surprised? That's a surprise. You know, it's a discontinuity in our understanding of the schedule. But should I have been surprised? Should I have thought about that? How could I have been aware? I used to train project managers. And I would ask them to create a list of the top 3 or 4 or 5 risks that they saw for their current projects. And I would ask them to think about how would they recognize that risk if it just kind of jumped out of the weeds and jumped on them. And I also asked them to think about how could they recognize that same risk a long way off. Come with me for a moment. We're on the veldt in South Africa. We're looking out towards the horizon, and way off at the horizon there's a cloud of dust rising. What is that? What's coming? There's something, but it's still a long way off. How would we recognize risks if they jumped on us? How would we recognize risks when they're still a long way off? And what would we do in each of those cases? So I'm focusing these days on surprise, trying to understand when I'm surprised. Why am I surprised? What did I miss? What could I have asked? What could I have known? What measurement might I have taken to warn me that this surprise was coming? So this is now my favorite indicator. It's not any of these metrics anymore. Surprise is my favorite indicator. I want to take just a moment and share with you something called the Satir interaction model. How many have ever heard of Virginia Satir? 1, 2-ish, maybe 3. Satir kind of single-handedly invented family therapy. Before Satir, if parents were having trouble with the kids, they just kind of dump the kids at the psychologist's office or the psychiatrist's office and say, here, fix the kid. And then they'd go do their shopping or whatever, and they'd come back an hour later and pick up the kid, hopefully fixed. You know, like you would drop off a bicycle or a car. Satir was the first one to recognize maybe it's not the kid that's broken. Maybe it's the parents. And maybe it's not both parents, maybe it's one. Or maybe there's an interaction between the 2 or the 3. And I have one of these. I used to have one of these at my house. Luckily, she grew up and got married. Now she belongs to somebody else. But, and her name is Dari, and she's a marvelous woman. But Dari and I got along just fine. Dari and her mother got along just fine. Her mother and I got along just fine. But put the 3 of us in the same room together, it's like, warfare. It was amazing. It's the triple. It's the 3 of us interacting together. And Satir was really the first to recognize that, hey, maybe this is what's going on in families. She has something called the Satir interaction model, which I'm not going to go over today in great detail, but I do want to tell you the first 3 phases, because I think it helps us with surprise. The first is called intake, the second is called meaning, the third is called significance. Let's look at those. Intake is the process of observing the outside world, bringing the outside world into our consciousness. That's what intake is. And as human beings, we can be surprised. We fail to observe huge amounts of information. We walked from an office building to a restaurant to a hotel last night and observed very little of what was going on. There were a couple of stores that piqued our interest, but by and large, we don't remember much of anything. Okay, there's just too much information. And so we ignore it. Now, some organizations maintain what they call an oblivious culture. That is, they choose not to observe anything. They choose not to do any measurement, for example. They choose not to ask why or try and understand. They're just kind of oblivious to the world. They go through the world with their eyes closed. Some organizations, some individuals do that. There's another kind of organization, an individual, they observe, but they quickly filter out the data that doesn't agree with their worldview. And politicians are wonderful at this. I'm not going to make any political statements other than that. But they are marvelous. They can look at absolutely the same data and come to totally different conclusions because of what they want to believe. Okay? Now, there's a third kind of organization, third kind of individual. These are really frightening. They actually prohibit their members from observing. These are the ones who would say, you can't go to conferences. You can't read books. You can't measure anything. You can't look at the outside world to see what's going on out there. Okay? So it's no wonder that human beings are surprised by things. Okay? Now, the second phase of the Satir model is called meaning. It's when we assign meaning, that is, we map our experience, what we've observed, to our context, to our feelings. And there are all kinds of things that get in the way here. Biases, agendas, pressures, expectations, even past unresolved personal issues. These get in the way of assigning the correct meaning to things. Human beings are notorious for believing that the first meaning that they figure out is the only meaning, is the right meaning. And it often isn't. Jerry Weinberg has this wonderful idea called the rule of three. He suggests if you can't think of three different meanings for the same chunk of data, you just haven't thought about it long enough. Take some more time, figure out some more meanings. And even then, once you have your 3 or 4 or 5, they still may not be right. There are lots of different meanings to data, so we can be surprised there. Now, significance is the next thing that we do. Once we figure out we bring this in and we assign a meaning, then we decide whether it's important to us or not. Bob gave a great talk last night and talked about a tool that Microsoft has essentially abandoned. And people say, oh, it's a great tool. Bob thinks it's a great tool. Lots of people think it's a great. Why have they abandoned it? Well, it's just not significant to them. They just have other things that are higher priority. Okay? They've said the significance of this is low. Okay? And we all do that. Okay? We make observations, we bring it in, we assign a meaning, and we decide that's not really important to me. And we can do that for a number of reasons. The observation may just not fit into our previous experience. We look at something and we go, I don't know what this means. Okay? We just can't evaluate its importance. We could be operating under rules that don't serve us well. Or we may have been conditioned to minimize the significance. Oh, we've seen this before, but it's never bothered us, it's never hurt us before, and so, it will be okay. Here are some significant surprises. My wife was driving down the road one day when this little oil light thing came on. But, she had to take the kids to soccer, and then she had to go to the grocery store, and then she had to do all these other things. And by the time I got there, the engine was a pile of molten metal on the roadway. She just didn't understand the significance of this cute little light. Okay? This is a great x-ray of somebody who walked into an emergency room, not really understanding the significance of what had happened to him. Okay? And how many organizations have you seen, this is the sales curve. And they look at it, it's just right there. I can see it plummeting through the floor, but they don't see it. They don't see the significance of that. Okay? We know the story about the little boy who cried wolf when there was no wolf, and he cried wolf when there was no wolf. And finally, when the wolf came, nobody believed in it anymore. His words just didn't have any meaningful significance. So there are all kinds of surprises. So what I would suggest that you do is, kind of hone your surprise abilities. Focus on intake, meaning, and significance. To learn something, when you're surprised, examine the surprise. What was the surprise and why were you surprised? And then focus on that, go even one level deeper. Say, well, why was I fooled? How did I get surprised? Why didn't I anticipate this? Why didn't I know? Why didn't I have some idea? Okay, well, we're almost done. We've talked about what is measurement. We've talked about the two basic mistakes that people make. What were those again? There's the something error and the something error. Map territory. And what was the other one? Reification. In other words, trying to count things that really shouldn't be counted. So Lee's Zeroth law of measurement, I hope you read Dilbert. This is one of my favorite cartoons ever. The pointy hair boss says, our goal is to write bug-free software. I'll pay a $10 bonus for every bug you find and fix. And the team yells, Yahoo. And then the boss, in classic manager form, says, I hope this drives the right behavior. Okay, this should remind you of Goodhart's law. Wally says, I'm going to write me a new minivan this afternoon. Okay. So, let me give you some words here from a famous guru and grandpa. And now, I'm pleased to announce I am a great-grandfather. Bentley was born just the other day. Thank you. I had nothing to do with it. And I saw Bentley at his parents' wedding. Process that for a second. In my day, we did it the other way around, but kids today, I don't know. So, I should change this. Famous guru and grandpa and great-grandpa. My words are these. Here's Lee Zeroth law of measurement. If you measure the wrong thing, and then you reward the wrong thing, don't be surprised if you get the wrong thing. I don't think that's rocket science, okay? But I see so many people who don't get it, who just don't get it. They measure the wrong thing, they reward the wrong thing, and then they get the wrong thing, and they're puzzled about it. They're just befuddled. So don't do that. So, what I've talked about in my time today, talked about what is measurement, giving that big definition. The 4 don'ts, remember, don't number 1, 2, 3, and 4. My favorite indicator, I've told you, is surprise, and I've shared with you Lee's Zeroth law of measurement. That's what I have to say. Here's a shameless commercial message. Some years ago, I wrote this book called Practitioner's Guide to Software Test Design. I'm still trying to peddle the book, Here's my email address. I'm lee@techwell.com. We used to be Software Quality Engineering. We were SQE for 20-some years. We just recently changed our name. Somebody asked me why, and I said, well, we don't write software. We don't seem to care about quality, and we don't have any engineers. So SQE just doesn't make sense anymore. So we must have paid somebody like $500,000 to come up with TechWell. TechWell? Oh, well. We do tech well. All right. Thanks again for inviting me. I love this conference. I love to come to your city. It's just a wonderful experience for me. Thank you very much.
Thank you very much, Lee. We have time for questions. Oh, come on, I'm sure that you had several ideas, right? We can count them. And you have several questions as well.
What's your recommended ratio for surprises?
You know, there's two kinds of surprises. There's the good ones and the bad ones. I like to minimize the bad ones. I like to maximize the good ones, although you can be surprised for too many things. So 6.3 to 1, I think, is the correct number. Right.
So
you do know that 47% of all statistics are made up. 47.63 to be precise. Okay. Anything else?
Now we got to target as well, right? Not only a measurement. Okay, please. This is your chance to ask Lee.
I'll be around all day if you want to chat. Be happy to chat with you. There's a gentleman over here. Another one over here, apparently.
Thank you. So it's just, you told us that we measure these things because they are easy. And you told us how not to do these things. My question is more about how to measure the things that are more complicated, or what should we focus on when we face a surprise. So do you have anything that is worth measuring?
No, I have nothing there for you. That's another talk. That's next year's talk. I like the things that Bob Galen has in his book about predictability and quality and happiness and things like that. I think that's where we ought to focus more. But I haven't thought enough about that yet to give you a good answer. But it's an excellent question. It's where do we go from here?
Okay, thank you.
And I'll just do the Socrates thing. You know, my job is not to answer tough questions. It's just to guide you and direct you, and so that you can do that. I'm not a one-size-fits-all person, so I'm not sure that there's a good set of common metrics. Yes, please.
My name is Laszlo, and I wanted to ask you, how do you sell this to measurement? But now you said don't ask for difficult questions, so can you sell this to the management? This your ideas that you present to us.
Okay, could you ask your question again? I'm sorry, I don't...
So can you sell this stuff to the management? Or how can you sell it?
How do you solve this management issue?
How do you sell this idea? So you tell them, okay, this is the right thing to do, but how do they buy your ideas?
How do you stop management from doing the metrics and giving targets?
That's another hour talk. I think we stop by our stopping. We simply refuse to do stupid things anymore. Hida, at her talk last night, was talking about ethics and testing and ethics, and I just think that finally you say to yourself, this doesn't help, this hurts, I'm not going to do this anymore. Now then you have consequences that may come with that. But I just think that it's up to us to say, if you want this metric, if you want me to gather, how many test cases I plan to create, what value is that? What are you going to do with it? How are you going to operate differently if that number is a big number or a little number? Or if it's 50 or 1,200? How are you going to use it? Or is it going to go in the garbage can? These things that I've talked about here, don't number 1, 2, 3, and 4, I think there are guides. If you're asked to do something that just doesn't make any sense, be gentle at first and then be firm when you have to. Just don't do, doctor, it hurts when I do this. Well, don't do that. Okay? Don't produce metrics that are goofy, that are going to be misused. I think we have a social and ethical responsibility? Another excellent question.
Okay, my question is, in case you do not discover any surprises or no surprises are reported towards you, then does it necessarily mean that you do not do the right measurement?
No, if you're not seeing surprises, it could be that your surprise threshold is set too high, or your ability to detect surprises. I'm surprised every day by good things and bad things. And I just think it's a thing you cultivate. Look for surprises. Then after you do well at that, then you can come back and start measuring surprises if you want. Then come back to measurement. But look at surprises first.
We have time for one more question.
One more.
One more. From the back, yeah.
Hello. The world is going to more model-based oriented in the development and the testing activities as well. Are you absolutely against this way? Or?
Could you repeat the question? The distance makes it difficult here.
The model is my focus point.
The model.
Yes, model-based development and testing activities.
Model-based testing, model-based development, okay.
Are you absolutely against this way? Because the world is going more and more model-based oriented in the development as well, etc.
Let me give you two answers on model-based testing. Model-based development or model-based anything. There are very few advantages. I'm getting old. You notice I'm sitting down instead of standing at the podium. It's not out of disrespect. It's just I'm tired. I'm old. There are very few advantages to getting old. There is one advantage, though, and that is you see things from a much broader perspective. And so the resurgence or the advance of model-based techniques today is not really an advance, it's just a resurgence. These things have been around for a long time. They come and they go. I wrote my very first object-oriented program in 1987. Long before anybody thought there was such a thing as object-oriented. And because I've been around for a while, I see things come and go. A new generation comes and they get excited about this technique or that tool or this approach. When in fact us old people know that it's just, it's just the wave coming into the shore one more time. So I'm a big fan of any of these tools and techniques, anything that makes our life less complicated, lets us be more accurate, whether that's model-based development, model-based testing, whatever. But Fred Brooks, over 50 years ago now, wrote an article about the search for the silver bullet, and I find people still looking for that silver bullet that's going to, cure all of the testing ills. This is hard work that we do. This is intellectually challenging, difficult work. And I love tools and techniques and processes, but I try to not get too enamored in those, because there'll be another one along. It's like the tram. There'll be another one along, and it'll look even shinier than the last one. And so use tools and techniques that help you. But I've seen so many organizations that just glom onto the latest thing. Ooh, Scrum must be good. Everybody's got to do Scrum. Without asking, well, what are the benefits? Does it fit here? Do we have the problem that it solves? A lot of pointy-hair bosses out there. So, yeah, I love these tools and techniques, but not the be-all, they're not the end-all, they're not the silver bullet. And And it's the pendulum. The pendulum will just, it'll swing. And they'll come into favor for a while, and then they'll be out of favor for a while. And, it's the only joy I have in getting old, as I see things from this perspective. All right, are we finished with the questions? We done with time? I think we probably...
Yeah, perfect with the timing. Thank you very much, Lee.